Hello, our project is an application development for cyber attack on Android and is typically embodied as a project of Keylogger. And firstly, I'm going to introduce an overview image of our project, which is mainly about the background and names. And then I will introduce some fundamental principles of our project. So let's start. When talking about the background, a very significant concern is about Android security. That is because mobile devices are becoming more and more popular, and Android holds top 1 status of market share. Therefore, the cybersecurity on Android is related to so many people that is definitely not ignorable. In addition, according to the research from CVE, there are many different types of vulnerabilities found on Android, such as DOS, code execution, overflow, memory corruption, SQL injection, etc. However, the vulnerabilities are not isolated from each other, which is typically shown as when the malware is running, there are often 3 or 4 vulnerabilities utilized to implement the attack. Typically, privileged escalation is a common weakness that is usually used to provide certain permissions to the attackers, which is a key step for malicious activities. Our project aims to explain and implement an Android cyber attack and provide a corresponding countermeasure. So let's go to the fundamental principles. Our project is basically a malware that can implement keystroke monitoring. That means when you are typing or actually touching the screen of your Android device, the history of typing can be monitored and recorded. It can be dangerous for users because the password of screen lock or their accounts for any applications can be stolen by that. Also, other kinds of privacy that entered by typing on Android are all under the risk of being exposed because of that. On the other hand, this malware can be not easy to be found because although it uses the function of toast on Android, it settles the color of toast as transparent. The toast is a function that often be used for informing or showing short images and videos. And its color is usually gray or dark, which should be conspicuous. And to launch this attack, a default constant of toast needs to be erased. So basically, the countermeasure is to make the corresponding constant mandatory, to eliminate the possibility of the attacking in this way. So that's all of the fundamental principles. The next stage, we will illustrate more detailed implementation and countermeasures for the attack. Thank you.
I'm gonna introduce about the flowchart of the application with a malicious code. When the user start the application, it's gonna hiding the toast, and after that, it's gonna remove flash non-chargeable, and after that, the application gonna register the keystroke, and the keystroke gonna capture like any data the user typing into the string of the device. It's gonna repeat again if the user haven't finished, but when they finish, it's gonna send the data to the internet, and after that, it's gonna check again if the application is installed. It's gonna finish the process, but if they haven't installed the application, it's gonna go back to here to like repeat the process. When I install the application gonna require for like a couple of the permission. They're gonna ask for access to the internet, the right to internal store in the location sometime. Yeah, and when it's collect the data by access the internet, it have to be access the internet to sending the data. And if the if the hacker want to like store the data into the device, they have to require the right internal storage have permission. To compare it with the normal application, it's very similar with the normal application. So that's why the user is very hard to know they got like the malicious code in the application or not. You can look in here. When they unblock the screen, it just unblock and block the screen like normal. But when they start the application with malicious code, when they unblock the screen, they're gonna send in they're gonna send the data when they talk into the screen to the dedicated address on the internet. And to implement the attack, it's very simple. Like when the developer, when the hacker, when they build some application, they just add some the malicious code in the application, and then when user click in like any button, it's gonna start the process to collect the data. And for the result, it's gonna collect like some data, the location when like where the user talks into the screen, or it's gonna be record and send into the internet, send into the duplicated address. And in there, when a hacker wanna like use that data, he have to encode it. Like he have to locate where the user talks into the screen, and then like encode into the real data, like the bytecode pin code of the device. For the solution to prevent this kind of attack for the user, when the user download any application, they have to check it very carefully. Like they have to download the application from the official market, from the Google Store. And even when they download it in the application, they have to check like the comment, rating, and rating of the application. And this kind of attack is use the TOS function on the Android. So the user need to update the Android version like because like any when the Google gonna update the new version Android, it define for the security reason, they're gonna to update to prevent the attack. And when they start a new application, when it's required like it requests some permission, check it carefully before the user accept the permission for the application, like the internet, like the location permission and internet permission. Now I'm gonna turn it to Michael to demonstration the application.
Hello, I'm going to demonstrate a malicious application. So it works by recording clicks on a toast. So you may say, how can you do this on a toast? Well, we do this by a vulnerability that was reported and patched in February this year. And we're running it on an old OS. And it works by overriding and removing a flag by reflection in the toast constructor called flag not touchable. And we do this over here in our click toast event, and we do it by overriding it in the TN object in the toast constructor. A flag keep on screen and over here, and we also make it transparent by recording clicks. We can send it on over online, so we can steal passwords, we can do all sorts of nasty things, read people's messages, and yeah. But we also need to override a dispatch touch event. There's a number of ways to do this, but this is the way we've done it, and we also were able to record the actual keystrokes. So enough talk, let's run this. Yep. It also takes no permissions. That's pretty cool. So I'll run it, and it works also if I close the applications, and down the bottom you can see the X and the Y coordinates of the clicks. So really big numbers in the Y here, really small numbers in the X and Y here. Accidentally clicked outside the toast, but the toast takes up the whole screen, and this is cool. Thank you for listening to our demonstration.